Hey everyone, this is Carl, and I'm just going over actually in terms of hypothesis testing. This problem is taken in section 10.7, problem number 11, and just kind of cut and dry for each of the following situations. Find the critical value or values for z. A, null hypothesis equals 0.5. Alternative hypothesis is p does not equal 0.5. Alpha, or the confidence interval, 0.05. Now what does that mean? When alpha is 0.05, the confidence interval for this particular hypothesis is 95%. 95% confidence interval equates to 0.5 alpha. And so 99% confidence interval, as you would think, is 0.01. So basically, when you're looking at confidence intervals on the flip side of this kind of value, it's 1 minus the confidence interval. That's what gets you alpha. And so this is very cut and dry, just getting to let you know how this works in Excel and just basically how we calculate this and kind of the nuances of this. So starting with the first one, null hypothesis 0.5, alternative hypothesis does not equal 0.5. And so when you have it this way in terms of it's equal and it's not equal, that means it's a two-tailed test because it's either this value or it's on the other side. If you think of it as this bell curve, that means that it's either on the other side of 0.5 or it's not. So it's kind of a good subtle hint, or actually very, very direct hint in terms of if it's one tail or two tail when you have it equals and not equals as compared to these other two, as I'll explain a little bit later. But going forward, so this is a two-tailed test. And what does that mean? So we know that this is a two-tailed test based off of this verbiage right here. So what we do is actually, that means we split alpha. It's alpha divided by 2 for a two-tailed test. So 0.05 divided by 2, and that is our alpha. In this case, 1 two-tailed. Now remember though, that you're getting both ends of the spectrum. You're getting both ends of the bell curve, the normal distribution. So one of these values is 0.025, and the other one is 1 minus 0.025 to get both sides. And when you have this two-tailed test, so 1 minus this. Oops, 1 minus. Let me just do this real quick. 1 minus that value, and that gets you what we have here. And so now in terms of finding the critical z value in this case, now there's two ways you can do it. One way is using a critical table from your textbook. The other way in terms of Excel is the norm sine function. So, and you'll see this, just basically it's kind of intuitive once you find out. So 0.025, the normal sine is negative 1.96. Now you flip it over to the other end, and actually what you would think, if in terms of our bell, if this side is in the negative, then this side must obviously be in the positive. And if it's a normal distribution and it's perfectly symmetrical, so as you would know and as you would think, it's exactly opposite, 1.96 in the positive. So those are your two critical values for z on a two-tailed test based on this information. Now moving over to the null hypothesis, 0.4, and the alternative is greater than 0.4. This is a one-tailed test. That means it's either not 0.4 or it's greater than 0.4. There's only one distribution that it's getting at, and it's greater than 0.4. So in this case, our alpha stays the same. We don't have to divide by 2. This is a one-tailed test. Two-tailed tests, if you remember, it's equal, not equal. One tail, it could be equal and greater than, less than, that kind of thing. So equal, not equal is a big hint in terms of if it's two-tailed. But going back to B. So now that we have 0.05, so now we basically, now remember, this is greater than, right? So this is to the right. So it's in the positive. It's a big hint. It's to the positive. So we are doing 1 minus 0.4. Or actually 1 minus 0.05. So remember, this is 95% confidence interval, just like before. So that is our value. That is P. That is what we're going to be using to, that is our alpha, I'm sorry. The probability that we'll be using. So just the same as before. So what is our critical z? It is the norm sine function of that value, of that probability. 1.64. And that's the critical Z for this, based on that, just to kind of give you a sense of the highlighting. And then we'll do our last one. Null hypothesis P is 0.5. Alternative is P is greater than 0.5. At alpha equals 0.01. Now remember, what this means, this is a 99% confidence interval. And N equals 345. So if you notice, this is it's basically the same as before. It's almost equal to B in terms of language. It's equal and it's greater than a value. Alpha, it's there, and they just added N. So what does that get at? So now remember, this is greater than, so we're doing this 1 minus. Same as before. 1 minus your 0.01. That's your probability. And so naturally, what we're going to do is use our norm sign function to get at this probability. And it will take us to 2.32 as our critical Z value. So what C tells us, I mean, there's really not a difference between the two, except this one has N. So the point of C is to let you know that in calculating the critical values based on these parameters, N is not important. It's not critical, it's not needed, essentially, to calculate these formulas, to calculate the critical value, based on the information that we have. So this is just kind of a quick rundown of the basic hypothesis testing and finding the critical value, when it's pretty simplistic, but to give you a sense of the norm sign function, as noted up here, for finding the critical values for Z when dealing with hypothesis testing. We hope this helps. Just let us know if you have any questions along the way. Thanks so much.